Hello everyone. Uh, Today we'll discuss about Kubernetes cluster, or you can say it's a Google Kubernetes Engine GKE. So please like and share my video. So it's my uh, website is a techizone.co.in, and then inside the cloud training you will get this video. Also my videos are available on YouTube. So So first of all, how does GKE works? But before that, I want to make you familiar with the Google Cloud or the Google Cloud console or with the GKE. So this is my Google Cloud console. This is Google Cloud platform. And inside that, from here we create the VMs. But if I'm going to the GKE, is a compute engine, and this is Kubernetes engines. So in the Kubernetes engines, click on the cluster, or also once you click on the Kubernetes engines, you will get the cluster option. The cluster is the very first option. First of all, you need to create a cluster, and in that cluster there are one master and one or more uh, nodes. It automatically deploy once you create the cluster. So once you create the cluster, is that there are two type of cluster. Is a GKE standard and GKE autopilot. In GKE standard, the nodes are managed by you itself. So is a always we go with the standard one. Is a more frequently used in the industry. So is a pay per node Kubernetes cluster where you configure and manage your nodes. Okay, but in GKE autopilot modes is a node is managed by GKE. So is a pay per pod, not per the node. Pod is the smallest unit in Kubernetes. So Kubernetes cluster where GKE manages your nodes with minimal configuration required. Okay, now come to the PPT. I will upload this PPT in my website, or also in the comment section you can comment and drop your email ID so that I can send this PPT to your email ID. So uh, put your email ID on the comment box, and also put the comment how you like the videos and what else you want in the Kubernetes, so that I can uh, mm, in the next videos I will include that things. But this is a complete series for Kubernetes engines, for basically for the Google Kubernetes engines, and in that I will show you how to create Kubernetes cluster and manage the Kubernetes engines in Google platform. So how does GKE works? Whenever you deploy a cluster, is a autopilot mode or is a standard mode, it's automatically create a zonal control plan and a node. Is a one node cluster or two node cluster, you can create that. So I'm showing you how it's creating. Suppose I'm going with the standard one, and it's deploying is a cluster name, is a zonal or regional cluster. So here in the theory PPT, I will show you what is zonal and regional cluster. Suppose in zonal is a in which zone I want to deploy this. If it's a regional, so in which region I want to deploy this, need to select the region, and the version, control plan version, static version or release channel, as well as I need to check this. So this is my control plan version over here. So once you uh, deploy the cluster, it will automatically deploy a zone control plan with the version number you need to select and the node. In zone control panel is basically a master server which is responsible to manage the nodes and the communication between user and the nodes. So zonal control panel is a here all Kubernetes objects in your containerized app run on top of a cluster, which is the foundation of the GKE. So foundation I have we need to create from here. So once you create a cluster, means we are creating the foundation. Here is showing some from the field are incorrect because I have US, Asia, Europe, West 4, Frankfurt, Frankfurt. Yes. So once you select the correct region in which you have created the PPC, then it will remove the error message. So in zonal control plan is a resource controller is the basic components of zonal control plan is the resource controller, API servers, scheduler and storage. Okay, cluster consists of at least one control plan or one or more machine nodes. This one, okay, one or more nodes which are created during the cluster creation when or while you create the cluster means this one and this one both. So and also the API server is communicate with the kubelets. Kubelet is the part of nodes. So here I mentioned the complete uh, circle, what is the use of and the particular things are here like Kubernetes API server scheduler storage core server controller. The control bay is responsible for deciding what run on all the clusters node. Okay, so deciding what runs on the cluster was this can including scheduling workload managing networks storage lifecycle scaling and upgrade. So also we'll talk about the auto scaling HA part of that. So this is mainly so once user is communicate with the through the kubectl command is run the kubectl connect with the API server and API server get the details of the scheduler storage resource controller and it's get connect with the kubectl kubelets to fetch the nodes detail and then it's replicate to the users. And now a node is a node is run the service necessary to the support to the containers that make up your cluster workloads, and these include the containers runtime and the Kubernetes node agent kubelet which communicate with the control plan and is responsible for starting and running containers as scheduled on the that particular node. Okay, ports are the smallest or basic as a smallest unit in the Kubernetes and most basic deployable object in the Kubernetes that are the pods are the smallest and most basic deployable object Kubernetes and um, contains one or more containers. Pods are also contains shared networking and it's, you can say it's a pod networking also the BP using the BPC how pods are getting communicated. So it's just a shared networking and storage resource for their containers. So it's a pod get connected or is a in communicate between is a like this is my Kubernetes container and inside that container I have multiple pods C1 C2 C3 like this. So in the nodes inside the node we create the containers and inside that containers we can create the multiple pods or multiple services running that like web service for another is Apache, one is IIS and one is an mail service like that you can create the multiple pods over there. So the mode of operation I already shown you that is there are two is a autopilot and standard. In standard you itself maintain the node And in autopilot, GKE maintains your mod. It's a difference. And next is zonal cluster and zonal. So about the zonal cluster, there are zonal and regional cluster as you shown in the here is a zone and region. So in the zonal cluster, there are single zone or multi-zone cluster we can create. So in single zone cluster, we our or multi-zone cluster in both, we get only one zone control plan and multiple nodes. Like here is a one is a single zone. We have one zone control plan and zone control plan is a multiple for. So in both, if we are going for the zonal cluster, we get single zonal control plan with multiple nodes. If we are going with the regional cluster, we can get mm, multiple control plans with multiple nodes. Okay, same. If you know about the regional and zonal cluster, so after that it's now times to know about the high availability. For availability, like you can choose between two type of clusters. I already updated you about the zonal and regional cluster. So is the regional cluster are better for the HA because they are multiple control plans like this. If you are going with the regional cluster, you have multiple control plans. So this is the best or is a better option for the HA. Okay, across the region. And in zonal cluster, you have a single control plan. So this this is always means that is a changes the cluster configuration take longer effect. So whatever you make changes in the zonal cluster, suppose you have multiple pods in a cluster. So whatever changes you made from here, it will take time to replicate. Okay. And if here you are making any changes from the control plan, it will take less time because you have the multiple options. They will share the workloads. So this is also means that the changes to cluster config that longer takes longer in the regional cluster because they must propagate across all control plans. Okay. Okay. Yeah. So whatever changes you make on the cluster in the configuration, it takes longer time in the regional cluster because you have multiple things to propagate from here to here, and less time because here you have a single control plan. So it's take the less time on the only the control plan I'm taking now. And due to this trade-off, choose regional cluster when availability is more important than flexibility. Always remember this thing. Choose regional cluster when availability is more important. And when flexibility is required, then go with the zonal cluster. And choose zonal cluster to create choose zonal cluster to create or upgrade cluster rapidly when availability is less of a concern. Okay, and now how to use GKE. So how to use GKE? We know that GKE works with the containerized app. So before you deploy your workloads on GKE cluster, you must first package it into the container using Docker. Also, before continuing this, I want to tell you one thing, that Docker is inbuilt in the GKE environment. While you're going to the GKE environment, just open the Cloud Shell, and from the Cloud Shell, you need to run a command like Docker version. So, on if the command is running properly, it means Docker is already installed. No need to do anything to install Docker. Just run the Docker commands and you can build the images. Like you want to pull the image, you can like Nginx image, any Alpine image, or Ubuntu image, you can pull it from the Docker hub. So now I'm showing the show is the Docker version. Doc. I'm showing this command because to show you that is a Docker is already installed. It's a 20.10.14 in the GK Google platform, Google console. So only what we need to do, so we need to deploy the workloads on GKE cluster. You must first create a package, or you can download the package or create a package using the Docker, or you can download the package from the cluster Docker hub, and you can use it in the Kubernetes. So create a continuous integration and continuous delivery. You can say this is a CI/CD pipeline. CI/CD. Okay. So to create a CI/CD pipeline, you can use Cloud Code to write your apps, which can then be stored in the cloud registry and ready to be deployed into a cloud build. So whatever you have make that ready the in the through the cloud code, you stored it in the cloud registry, and then if it's ready to deploy, you can then create a GKE cluster using cluster console UI, and these are the things command line. Well, this is the possible ways you can create the GKE cluster. How can you create it through the GKE cluster using UI or the gcloud command line, or the using the API or kubectl CLI command, so that you can create the GKE cluster. So the first way, you need to create a cloud codes, and then is put it in the cloud repository, and from there it push to the build the process of the cloud build. And while you build this process, put it in the cloud registry, and then deploy your GKE engine. This is the process, whole process. And after that is a GKE four-way of auto scaling. There are four-way of GKE auto scaling. Is the first is horizontal pod auto scaler, is the HPA, and vertical pod auto scaler is a VPA. So in the HPA is a you can increase the number of pods, and in VPA you can create the sizing of the pods, like you can increase the memory, CPU, all that. And is a VPA and HPA comes under the workloads. And another is the infrastructure type of auto scaling, in which cluster auto scaler is a CA. In that you can increase more nodes, number of nodes you can increase. And in node auto provisioning, NAP, NAP, you can increase the node pools, how many pools you want to increase. So that this is about the auto scaling. And in the at the last end of this video, we'll tell you about the basic networking mod. Is a BPC network. Suppose this is your BPC, and inside that BPC you have created uh, Kubernetes uh, BPC or primary or second a BPC subnet with a primary or secondary IP address. So this is your primary CIDR range and this is secondary CIDR range. And inside that you have created some nodes is a Kubernetes. Inside that node is a pod, and this pod or is a Kubernetes nodes are using the secondary IP or alias IP range. It automatically takes the alias IP range from you. So this is how this primary or secondary CIDR is used as a alias IP. So it's take the secondary CIDR range here in the node Kubernetes plus nodes in the node 1, and inside that node 1 we have created the different parts. So see you in the next video series. So please uh, put your comments in the comment box and like and share my video. Thanks a lot.